Hello, and welcome to this part of the stream. Let me see, let's just do some basic setup here. Uh, so during the last episode, I ran into some problems in terms of NVIDIA Insight not really working anymore. I upgraded my drivers, I updated um, yeah, whatever I could find to upgrade, and yeah, as you can see here, the frame debugger just hangs and doesn't do anything, although the application works fine. So I'm guessing that it is related to the um, NVIDIA software, even though I tried upgrading to the latest version. It doesn't seem to work out. Uh, so I decided to take the step and let me see. Hello, welcome, uh, and uh, and use RenderDoc instead. Yeah, did the notifications work this time? So I have to get used to this kind of layout instead. But as you can see here, the functionality is pretty much the same. Um, we capture a frame, we can store different frames, which is pretty cool. Then we load the frame capture and we can do some different event browsing here. Uh, yeah, so we can actually expand and close on the frame. We can also do our resource lookups as before. Yeah, but I'll try to get used to the new layout. No, no, no. I only have a 2060. I haven't had really the yeah. I haven't found the current GPU prices to be um, kind of like conductive to doing a purchase of a new GPU. I would surely love one, but I think I'll need to hold off on that. How about you? Um, yeah, I do. Um, so we uh, should test our new class here. Nope, nope. And yeah, it's pretty nice. Wouldn't live without it. We patented the device. Yeah, I deleted this code during some testing. Let's do the size of the object data here. And then we would like to try a allocate dynamic, and then we would like the CPU address of the second, meaning the third allocation. Let's do what we did before, temp data, and set the texture index to 32 and the material index to 42. I'm gonna do the buffer allocator, which I started on last stream. It's supposed to be a way to submit um, rendering information dynamically for each frame. So we do get the CPU address, we do the mem copy for testing here, and we want to copy from our source data here, and we want to copy in terms of the size of our object data, and this should be it. I was just about to use Insight, but it doesn't work, so we there we go, and we capture a frame here, and let's check out our resources. We have a don't we have our stuff? Let's see, static, dynamic. Well, which one? Oh, uh, let me see. No. Let's try a new capture here. Well, I don't create them for some reason. Did I miss some part of the... I mean... No, no, it's not more complicated. I think it's just... it's pretty much the same in terms of complexity. They're almost the same. I mean, aren't we supposed to... Um, you could call fences semaphores. It's semaphores are just a way of expressing synchronization points, and DirectX has a lot of different synchronization object data buffer. Oh, maybe did we? No. Let me just check here. Does this fail actually? Yeah, so the terminology is different, but in principle they do the same thing. Some people like Vulkan better than DirectX12, and some people like it the other way around. In reality, I don't think there's a lot of difference. Okay, if we do this, we should see, well, I don't know why I'm not seeing uh, what I expect to see in terms of maybe we reference all resources. Maybe we want that instead. Let's see. Yeah, there we go. I guess you could say that it's really up to the programmer to make sure that happens. So the APIs just supply the kind of tools to do it. So you could, if you're good at Vulkan, you can probably outdo someone who is mediocre at DirectX 11. So there's no, I don't think there's really much difference. Probably maybe in the small percentages of things, but I think it's more of a, well, I don't know. I don't know what the differences are, so I couldn't really say what actual differences are. But let's see, flow. Do we have this? Oh, maybe just int. Let's try that. And then we need some padding, of course. Okay, we have some values stored here. Okay, so we can. Yeah, all right. Have a great time. So there is some information starting here. Byte range start. How do I manipulate? Oh, you can save paddings. Okay, the row offset. Let's do 256. No. Okay, that's the base byte offset, right? Yeah. Let's do 512 here. All right. So we skipped the two first constant buffers that were stored in memory, meaning that we now have the third one, which has an identity matrix, uh, and then the numbers 42 and 32, and then some weird data entry. But 32 and 42 is actually our data points. Maybe it's some kind of like endpoint for the buffer itself. That's weird. We don't see anything like it in terms of the other. Hmm. Well, it doesn't make a difference. Let's do 768. Yeah, so it might be some kind of delimiter of sorts. Okay, but at least as you can see here, we can now write the constant buffer data directly to an allocation. Which is great because that is basically what we wanted. We wanted an allocator that could index into a underlying buffer in terms of in terms of constant buffers. Great stuff. I think everything works as intended. Mm. Mm. Let's try using the buffer allocator. Okay, so Right now we don't want to reset it. Right now we don't use the material and texture index. Everything will work completely fine. But let's say that we wanted to test out our system. We know that this data field right now is unused and will be used for testing. Um, we do our MC buffer, and we allocate a slot for this buffer here. We could do the same thing here. We also want a memcopy where we ask our new allocator to give us the position in memory. And we of course want to well, do we only want to, well, that's an allocation. This just stores the yeah, I changed oh, this is the actual work submission. Let's just revert back to what we did. I thought we need to use the static uh, data allocation instead. I thought that everything looked a bit weird. Materials, models, objects. Here we go. So this is disabled, or rather not used. Same goes for that. Let's do a temporary testing data field, and CB buffer allocator, allocate dynamic. And we of course do the exact same thing here, except we use this data field. So we will also do this for testing. We will instead do the MC B buffer get CPU address corresponding to rendering items with an index of I dot material index. That was our testing field. And we of course, since we offset the byte pointer, we want to prefix it with that. Yeah, everything is kind of the same. Let's see. We only swap the void pointer part. So now we should be able to copy our information. I hope everything will compile. Yeah, everything compiles. So now comes the interesting part. Are we allowed to swap this call here with our new buffer? let's try it. CB buffer allocator, get GPU address for the item dot material index. All right, let's try it. Well, something went wrong. Let's check out render docs. Doc. It's not plural. Let's see. Let's compare our data here. Dynamic constant buffer. View contents, a float 4x4, float 4x4, then unsigned int twice, apply. Well, we are missing some data here. Oh, wait a minute, wait a minute, wait a minute. I think I know why. Or do I? Let's just print this for good measure. Yeah, so it does get loaded correctly. I'm thinking that oh, we're missing the world matrix. Well, that is probably why we saw some data getting transferred and some not. Okay, the last one is a object that is allocated or rather updated in a different way, so it will only have the pre-initialized information. But it seems like we actually succeeded in swapping our uh, what do you call it? Our allocation references to our new system. We could do one last fix for this part of our system. So we could swap this for our MCB buffer allocator, get CPU address for the specific index. Let's do game objects go transform. There we go. I think this will be the last fix. Let's see. Yeah, there we go. Now everything is back to normal. We can even shove our dude here. All right, great stuff. So this is basically part of our system migration. we can now dynamically set, let's see, let me just store this in the section down below. We can now use our buffer as a write destination for every object that needs a dynamically assigned constant buffer. We will right now support a maximum of I think it's 256, but we will we do like that, just so we start taking care of our system limitations, and don't forget that we need to fix up some different stuff. But yeah, whoops, we need a parenthesis at the end, yeah. Okay. And each frame you call the end frame function, and then yeah, we reset the pointer to whatever is first in our buffer, and we start writing to that. Let's also implement a method where we kind of like copy our data. Well, maybe we want to do that later. Yeah, I might redesign some of this in the future if performance is too slow. I would like to be able to copy a batch, since everything will then be cached. Yeah, in general, I'm a bit ambivalent in terms of the general structure of things. Right now we use classes, which might be fine. Yeah, I would prefer to do it more procedural, I think, but yeah, maybe I'll do that in the future. Do a somewhat rewrite of everything into a procedural style. Yeah, I think for performance, the most important thing is when you do a lot of allocations. Maybe you try to optimize for instance, you could do something like allocate, maybe something like allocate block instead. And you could do something like a copy block. Actually, we will do a declaration for that copy block where you set the source data, where you set the const unsigned int chunk size, and then the unsigned int total chunks. So you would basically, when we do, for instance, this, you could do something like a vector of object data here, temp data, let's call it that, and you could do temp data dot data, where this is basically an object pointer where you could cast it to a void pointer. You don't need to, but you could do that, and you would know that this is aligned in memory on the heap because of the way the vector works, and then you simply know that yeah, it wouldn't be padded though. So you could do some kind of algorithm where you um, specify the yeah, you could do the spacing in terms of memory in the destination. You would do several calls to memcopy, but the the source data would be aligned in memory, so it would be fairly easy to read, and the write destination would also be somewhat continuous in memory anyway. So yeah, I think we could just do it like this. Um, let's call it a chunk, copy data chunk. Uh, maybe store dynamic data chunk, because it's only for the dynamic pages. Actually, I think that we might disable the static ones for now, since maybe we even want a separate system for that. Because right now we don't do static pages of allocations. All right. Now I'll let me see, std vector clear resize. Oh, okay. So this is actually a lot more useful than I thought. Well, it makes sense that they don't do allocations and deallocations over and over. Anyway, we will well then we can just hmm, mm, uh how nice of you. So we do some uh let's do something like this. Um, where we need the same information here. I don't think we need the object ID anymore. Uh, let's see. Whenever we submit something, the material buffers is not relevant. The models, the meshes are fine. We don't need that. We have the game objects. When we preload the static things, we kind of just copy information. Mm. So in our constant buffer, we store that information. And we could even collapse it into yeah, I think we could clean it up a bit, but well, so why would I need a object ID? I don't care about the object ID because I don't need to reference it since this will be a dynamic submission. So I don't need that. I also don't need the material index, or this is just for temporary allocations. Yeah, it's fine, man. As long as you're doing something that you like, it's perfectly fine with me. I like the company, but you shouldn't feel obliged to stick around. So okay. Let's revert back to the old system for now and do a parallel uh, set of draw calls, which will be our dynamic stuff. So let's see. Let's just revert back for now. We can save it for later in case we end up deleting it prematurely. So we will do this as per usual. We will move this. We will do a actually we don't need any of this, which is why it seems like a better way to do things, at least for now. Do I have to pre-declare it? I think so. Testing. New system test. Let's do a render draw call. Dynamic draw calls. And then we will do call. And we will do maybe just item. Then I don't need to change the thing there. Oh, okay. I actually do need to store. Yeah, one index. I need to store. I need to store CB index. There we go. So now our system will be able to draw dynamically set objects. Let's see. Yeah, we swapped that around. Let me see. Oh yeah, I forgot to change the update step back, of course. We're not. We're down. Yeah. Let's swap that back. There we go. So now I'll definitely have to do some refactoring here, clean up the system in total, but let's do another submit function. Submit render objects. Now submit well, render submit game object data. Let's just do that naming for now. I'm not sure what it's supposed to be named, but we will do a game object list here. Whoops. Objects. We will also grab their transforms. Object transform. And a reference to the game meshes. Then we want to do something like an for loop over our objects. And we want to create a render draw call. Draw call. This is only supposed to happen once each frame. Therefore, we end the frame. Maybe it's not supposed to be here. Maybe it's supposed to be called reset instead of end frame. Maybe we want that instead. Reset. Reset. Frame reset maybe. Okay. We want to do something like this, but we want to use the index. And we of course do a draw call constant buffer index to our new allocator. Gets allocate dynamic, and then we draw call. What did we call the buffer? We called it no, not C. Dynamic draw calls. Draw call, and we simply just move it. Then we want to. No, we don't want to move it until we're done. Yeah, so let's copy our code from before during the static stuff here. Let's not do that anymore. Let's move it into here. All right, and we of course need to set our material and texture information here. Okay. Okay, where do we grab the texture transforms? We actually store them as well. Okay, we pass in the texture transforms as well. Not preload static, submit object. Did we? Well, we did it after the regular transforms. Let's see, there we go. We pass in the texture transforms. And we access the object here. Let me see, how do I allocate those texture transforms? Texture transforms, one for each object. Okay, so it's related to the object ID. All right. Okay, and we objects dot I dot transform. All right. We do this kind of copying outside the allocator. We could do it differently. Let's see, does it crash? I think everything should be fine, but you never know. Anyway, nothing gets called, so therefore we have no crash. Uh, I think we would have whatever, we need to actually upload our resources dynamically now. So how do we test it? How do we test it? Well, we could do a call to this function every frame and see how everything turns out. Right now, nothing should have changed. Okay, let's try it. Let's do a application call here. So after we do our renderer here, renderer update, we do submit game object data. We do a std vector Let's see. Yeah. Temp objects. This will not be final code, but transform. Let's see, object transform, texture transforms. Object transforms. Well, transforms. Vector texture transform. Temp text transform. So we simply pass in that, that, and then meshes. Okay. Right now everything should work fine. Yeah. Let's try adding some stuff here. So object ID doesn't really matter. Anyway, let's do a game object here. Let's do this inside a scope. We don't care about the game object. We do care about the material, mesh, and transform. If I remember correctly, yeah, we can set the transform, but since we will be creating a well, this will work fine. We could do, yeah, we could do some stuff there. Okay, let's do a transform. A bounding box is not needed. Object tip, excuse me. And then we do a object transform. We can also do a simple texture transform here. Whoops. Simply copy that. There we go. Let's do a object transform. Sure, man. Good luck. Thanks for dropping by and hanging out. Let's see. What is the simplest one that we have? Well, the floor, perhaps. It depends on how much time and energy I have. Yeah, I might be, yeah, I'll probably do another break, maybe in a half an hour, and I might be back later tonight. Okay, let's set the transform information here. And let's place the yeah, you're 1 hour ahead of me, so maybe our schedules will overlap. If not, have a great time and stay strong. All right. Uh, uh, do we actually get a draw call? Let's see. Yeah, we do get draw calls. Sure thing, buddy. Have a good time. Stay well. All right. So let's see. Let's do the so transform 0. We upload that. Uh, oh, okay. There we go. Maybe it was clipping. So now you can see this object here is actually dynamically drawn, meaning it's submitted every frame to the rendering queue. Yeah, and right now it has no condition or anything, but that's handled in a different part of the system. So yeah, we could do this kind of stuff up here. Testing stuff. And for instance, we could set the temp objects instead of doing this, we could do temp objects texture to something else. And number 2, maybe we do number 3 here. Well, nothing really happens. Maybe, well, maybe it doesn't matter. Oh, it's only for 1 frame. Of course, it gets created every time, so it just gets reset. That is why nothing happens. Okay, we can do something that is totally silly, like a unsigned int temp value, which will be 0. No, I mean, let's set it to 3. And no, we do. So we simply set the texture to our temp value. Now it's stored between frames. Great stuff. Yeah, and we go out of bounds. Let's see if we set it to set it to 0 instead. Great stuff. We have now created dynamically drawn objects that get submitted every frame. Let's see. And we could, of course, optimize the code a bit. This basically means that now we can actually create yeah, we can create draw calls during runtime, which means that we can spawn objects, we can remove objects. Yeah, which is great. So I was wondering whether to do a specific system for this, but since vector.clear retains the allocation and we use it unless it needs to resize, I guess we're in good shape. Yeah, I do think I want to maybe just do a well, if you don't call frame reset, if you don't call frame reset, this is actually the same thing as a static allocator. I mean, you simply just keep on calling allocate, and the index increases, and you can always just keep on storing information. We could do something like, yeah, we could do a system where we allow static and dynamic allocations. Let's refactor this a bit then, and just call it buffer pages. Buffer pages. We don't need that. Current buffer index. We don't need to work in that file for now. Current buffer index. Let's see. We do a reset of that. We do like that. We don't need the static one. We will simply just create two allocators. And we will of course call release whenever we need to. Total CB is available. Buffer allocator. And we will do a buffer allocator public enum class dynamic and static type, and we will set our buffer allocator type allocator type equals type. Let's see, maybe we can do type dynamic allocator type. Let's do it like that. It's more readable. And we of course do call that, and we do a this just needs to be an if statement. If equals type dynamic allocator type, of course. Allocator type dynamic. We do like we do here. Otherwise, we do. Let's just be verbose here. And else we do a gxe assert false error unknown allocator type. Okay. And well, does this compile still? It should just be a default. It does. Great stuff. And we of course want to uh, we haven't implemented that yet. Allocate. Uh, and we do an allocate in our renderer. Dynamic draw calls, it's fine. Yeah, we want to migrate this. Let's see. We want a buffer allocator CB static allocator static CB allocator, and we do dynamic CB allocator, and we do buffer allocator type dynamic. Let's see. Submit object. Did we? No, preload static object. We actually don't want this anymore. I'm pretty sure I don't need it. Does this work? Everything works. All right. Okay. Let's do the static allocator initialization. And we do the same thing for the allocation sizes. And we do. Can we actually just do? No, we need to. Yeah, it's a bit ugly, but static. All right, and inside our buffer allocator, we do the 3D default heap and the 3D resource state common. And let's try that. We don't get any errors, which is great. Um, let's do a bit of a change here. Render item, integer, CB index. Our models get uploaded there. Here is our information. Do we actually transition the queue upload? This is the linear buffer. Destination. We of course need to migrate the resource. Let's see our resource state manager here. Transition. How do we upload stuff? Well, we haven't really bothered with uploading anything particular. Yeah. This is something I probably don't need. Let's see our upload here. Yeah, it closes the command list. So if I do proper registrations, well, no, this is the copy command list. Yeah, we could do a call. Where we synchronize. Yeah, so we don't need the percent, but okay, we will simply redo some stuff here. Let's store this for later use. So let's see. So we will change our static allocations here. I was just contemplating whether this made sense, but for now we will use a system like this. Let's do a rendering items, old buffer. And render item for now at least. Static draw calls. Let's see, I changed this one, so I need to update it. Yeah, and we will basically change this to our new data structure. Will we simply just use the newly defined struct here? Maybe, yeah, maybe yeah, I think so. We will actually do render draw calls. We don't need to store that information anymore. Static draw calls. Let's do some processing here. We of course want this information still. We will do render draw call, and we will set the information like that. Our draw call constant buffer index is going to be our static constant buffer allocator, which we will call allocator on. And this will allocate a slot, which will be stored, which is basically all we need to record a draw call. I mean, storing all this information kind of like, yeah, it wasn't great. All right. Right now, our buffer will be created on the GPU, but it will have no data. We will have to use our linear buffer to upload the data. Before we can do that, we need to transition the buffer. As you can see here, maybe we're actually we don't need to change the resource state. Maybe we can just queue the upload anyway. We would have to basically, no, we don't need to repeat that. Let's queue an upload of, well, offset destination. Okay, maybe we want a way to return an unsigned integer of get off byte offset. Maybe we would want some of this to be inline. Let's see. Yeah, we could make all of this inline actually. Well, let's just do this. Since it will be index times the allocation size. This will be so fairly simple that we will inline it. We could do the same in terms of the other functions, but well, yeah, we could do that. Maybe the compiler will do inlining for us anyway. Okay, we take our static constant buffer allocator and get the GPU address indexed for the 0 index, and then we offset by our aligned constant buffer data, and we kind of like well, I mean, maybe we want to simply store and this is also, of course, for each item. So the data is right now stored in, yeah, maybe we want to precompile some object data and well, what if the object data goes out of scope? This is not during runtime, so it doesn't matter that it's kind of slow. Since we will queue and wait for the upload anyway. Okay. At least it's a way to solve it. Let's do a vector of object data, temp object data, where we well, we compile the object data. The material index is supposed to be our game objects here. Material. Texture index, not texture transform, texture index is supposed to be our texture. Our world matrix is supposed to be our object transforms, offsetted by our game objects I dot transform. And since and let's copy the actual matrix. And the texture transform is going to be our text trans. And yeah, I think these are mirrored. They at least should be, so. And temp objects std move the object data. Oops. Obj data. Let's do a reserve of game objects size. And now we can simply reference our data point here by passing in our information here. And let's reference it. There we go. And then the size of our object data will be copied over. Oh, okay, we need a method here for hello, how are you? Welcome to the channel. Maybe we just want to return a reference. Get resource. Okay, let's do a get resource function call instead. This should simply probably depends on how new you are. Yeah. But if you run into trouble, I will live stream regularly and help you out. Also, another viewer asked that I do a complete beginners tutorial live stream, which I'll move to the video archive. So I'll do that in a couple of days, and then you can follow that. That will be completely beginner friendly. At least in terms of the DirectX stuff. Have you done programming before? Let me see. Can I find the mouse there? And let's try checking out the resource inspector here. Let's see the static stuff. Oh, oops, I renamed it. Let's see. Let's change one thing here in the buffer allocator. Dynamic. No, let's do upload heap here. And here we do default heap. There we go. Let's recompile and close a lot of this stuff. Let's do close capture, no. Launch the application, save the frame. Okay, then you could probably follow along. When I do the beginner series, it will definitely be easier. Let's see, I do get the... Oh, wait a minute, I haven't... Have I initialized it even? Have I? I probably have. Yeah, I do. Static. Default heap. It doesn't register or what? Let's see, launch, ref all resources. Sometimes it doesn't. Hello, welcome. Okay, there we go. So we do have both a default heap and an upload heap here. Let's see, view contents. There is some content right here. Yeah, but be sure to check in whenever I do the beginner's guide tutorial because yeah, that will be probably a bit more continuous and easier to follow as a beginner. Okay. Well, does this even look right? Let's save this format. Object data. Okay. And you're welcome, buddy. Okay, so this is... Oh, wait a minute. This is not the actual data I want to compare to. The default heap here. Wait a minute. I think we need to... No, we will do the weight inside the render stuff here. Offset destination. Do I handle that properly? Oops. buffer region, destination offset in bytes. Uh-huh. Hmm. Hmm. Okay, I really prefer NVIDIA Insight. It's so sad that it's buggy. Let's see. Let me just give it one more go to see if I can get it running. Well, it still doesn't work, it seems. So sad. I really gotten used to working in it. Anyway. Q capture frame 0. No, maybe not frame 0. Maybe just like this, and then let's see. Inside our resource inspector here, we will look up the this actually looks like an object of sorts, but we have some garbage values here. Which I don't like. We probably shouldn't have garbage values. Okay. Do I really need to pad it? Okay, we do something else here. Just try to write the first part of the information slash buffer here. And let's try that. No. Let's view our contents. All right, right now the garbage values are kind of gone. And if we queue up another upload, let's try that. And we simply store our object data here. Okay, need to close that. Let's do a new frame capture here. And well, that looks a bit weird, doesn't it? But let's compare it to whoops. Let's compare it to our object constant buffers here. Is that the same thing as this one? Yeah, it actually looks like that. So this constant buffer, oh, what is going on here? We have something else entirely. Yeah, it would end here, I think. No, it would end somewhere over here. And then we simply have zeros. My idea for the game, or what I'm doing right now. Let's see. So yeah, this is aligned to 256 bytes. Let's do 128 here. Step into the halfway point. Nope. Okay. Let's do a offset here. Well, this looks pretty much like our. Let's see. Can I? No, I can't open it anymore. Let's close the pipeline state and stuff here. We don't need that for now. Uh, so our second entry is actually exactly the same, so it does get uploaded correctly. Um, I'm unsure what this value actually is. Is it just, does a struct store a pointer to itself, or why do I have garbage values? I mean, is it because does this work now? No. I really don't know how to use render docs that well. What does this actually mean? Let's just try. Nope. Float. Nope. Double. Nope. It's just some kind of random information, but we probably shouldn't care too much, but yeah, I'm kind of like confused about it. Maybe it's just padding. The application will probably not read it, but I will have to be mindful of uh, this in the future. So this only stores one object right now. Yeah, so maybe our call here was actually correct. You'd hope that, at least. Let's just test it and see if the GPU knows how much to read from it. Let's see. Yeah. I don't know why it would store additional information, but well, I guess it doesn't matter. Okay, so this should, if we store the draw calls here, make us able to do some static draw calls, which with the same buffer allocator as before, as we've implemented. Let's see, let's store the draw call in the buffer, or vector, what you would like to call it, array. And we do that, and then we can simply swap our old draw call here. Uh, and we do like this instead, but instead we do our static constant buffer allocator. Let's try that. Hopefully everything works. Let's see. Everything works except the updating step, which is alright, because these two objects here are not supposed to be um, static objects anyway. We would probably migrate them into a dynamic system. Um, so everything works as intended right now. There are, of course, some different issues that we want to change. Yeah, so that's great. So the dynamic buffer is for uh, objects spawned at runtime creation each frame, which is actually this one right now, and the static buffer is for everything else. Great stuff. So now we can do a bit of housekeeping since we changed our pipeline here. Hello, and welcome to everyone dropping by. Yeah, it's probably a good idea. Let's delete this. Yeah, that's awesome, man. Congratulations. The first 3D model is always awesome. Trust me, the math will get better though. Okay, let's see. I prefer not to answer that. I'm sorry. I prefer to be somewhat anonymous since I work a public office, or not an office, a public job. So yeah, I prefer not to be recognizable, at least for now. But I'm Scandinavian, so you might hear it from my voice. How about you? Scandinavia also? Great, man. I don't know if I butcher your name, uh, Ryan, but I'm unsure what you mean. Do you mean if I can do other streaming services like X, or what did you have in mind? Right now, this will map to Joshua. I Do you mean how you should learn C++, or? Oh my God, dude, that's awesome. Do you do Euler angles, or do you do quaternions? Well, you could probably implement it pretty quickly if you're using Win32. It's just a Windows message, I think. You could just translate the camera alongside the viewing vector. Ah, okay. Yeah, so it's basically Euler angles, right? I find that that works pretty well for just well let me see. I'm not a math expert, but I think it's when you rotate around the different axes in radians or degrees. Uh, yeah, yeah. I also do camera rotations that way. Whoops, I totally forgot I changed the code. Yeah. Do you use the DirectX Math library or something else entirely? Ah, yeah. Well, then it handles that for you. It's a really nice library. Ryan, I also stream on Twitch. You're welcome to tune in there. I prefer to stream on YouTube, but yeah, yeah, there are a lot of different ones. Yeah, really. And it's also possible to compile in a highly optimized manner by using SIMD intrinsics. My math library is heavily inspired from the DirectX math library. Other parts I've done myself, but yeah. And even other parts are from Stack Overflow. Yeah, Joshua, I really know. C++ is so hard to getting started with. My advice would be to maybe do a few basic tutorials and then try building your own program and seek out help whenever you don't know why the compiler gives you errors. Just make a simple program, for instance, a calculator or a text file parser or something like that. Um, as long as you try working with pointers and get a grasp for the pointers, I think you will be coding in C++ in no time. All right. Right now we don't update each frame, which is all right, but it looks kind of weird and our player model there doesn't move anymore. So I know the feeling. But it's a learning experience. Hopefully we'll get better sometime. Let's see. So right now we could. Yeah. I know how you feel, or at least what you mean. Uh, yeah, that's just the way it is until you realize what the system tries to do, I guess. I really like the data-oriented design philosophy. It really helps me kind of like realize what I try to do. It's just very focused on how to do computations over data and changing data uh, through several steps. I do find it more easy than trying to figure out some stellar design or underlying philosophy. But yeah, my head starts to spin when I do multi-threading stuff. It's really hard. Hmm. The problem is that right now the pipeline is set in such a way that um, we actually don't have any way of updating the static objects um, because they are located on the GPU and not accessible from the CPU side. Um, So do you mean actual textures as in texture mapping, or do you just want the vertices to have a different color inside the rasterization part of the pipeline? Let me just show you an example of what I mean. Um, Render AQ. Do you mean like this? So that every vertex has a different color so you know which vertex is which? Or do you mean something like what I do where I render the whole model with a specific texture? Don't mind the bugs right now. I'm in between phases. Uh, well, I can't. I really don't know DirectX 11 that well. I only done DirectX 12, but um, my materials and SRVs, meaning textures. So uh, I'm so sad NVIDIA Insight is not working properly. I don't know why it doesn't work. Um, the SRV is a shader resource view, so usually it's a texture, but it could be a buffer of different sorts. But maybe I can root signature. Can I show you? Yeah, that's the typical thing. But there's something for each pipeline called a root signature. Maybe DirectX11 hides it by some different API calls, but you can, as this graph here shows, bind descriptor tables, which means that only one slot is a whole table, and you can fill that table with references to different resources. So you just need some way of linking the table index to your model. So what I do is I pre-create some textures, which I create descriptors for, which I reference in a table. Yeah, it basically could, but uh, okay, maybe you're actually talking about something else. Let me show you UV mapping, DirectX 11 perhaps. So, for instance, this is a UV map for a dice. Uh, and this is basically information you store for each vertex. So let me show you in an OBJ file, which is actually the file format I use. Let me see if I can find a model that has a interesting model here. So this is, of course, the vertices. Let's skip them. And now we get to the UV mappings. So this is for one vertex, a UV map, meaning that you have that would be pretty hard. It would be easier to rather combine the two images into one texture and then use UV mapping to determine where to sample from in the texture. So UV mapping is always done this way in DirectX, where the top left corner is 0.0 and the bottom right corner. Oh, okay, yeah, exactly. Um, so let me just copy this image over here, and let's say you have a split here where you have text 1 and texture 2, and then no, there's no limit because it's always normalized in terms of UV coordinates, meaning that the UV coordinates will never get greater than 1 on the X and 1 on the Y. So no matter how big your texture is, it's only a matter of kind of like scaling the whole thing to suit your vertex. Of course, with rounding errors, there is a limit, of course, but since GPUs use double precision floating point numbers, you should probably be fine. Um, so, for instance, if I want this side of the object to be, let me see if I can do I can't really do that. Let's see. So let's say this vertex gets mapped to 0.0. This one gets mapped to 0.5. So this means that it would be, for instance, 0 and 0.5. And then perhaps you map this vertex here to, let's say, 1, 0, 5. Whoops. That would be down here. And then the last vertex, let me just circle the vertices, I mean these ones. So if I map that one to R0 dot 1, oh, I think I made a mistake here. I've made a mistake. Yeah, this doesn't make sense. Sorry, let me redo the stuff here. Yeah, that is probably right. So let's do this one. Let me just scale the text size a bit here. Let's do 0, 0. And then this one. Yeah, it does. That's quite high resolution. Usually you would do something like that to store maybe some information in a compute shader or yeah. So the x of course is 0.5, 0.5 and 0 here. And then we do this one for this vertex here, which will be 0.5 and 1, and this one, the last one will be 0 and 1. This would mean that this part of the texture here would be mapped to this side of the object. So you need UV coordinates for each vertex. So you kind of need to upload that to your shaders, and yeah, in your shaders you need to do computations or sampling. You also need a sampler which controls whether the texture gets wrapped or if it gets stretched or offset or whatever, and also the filtering. Yeah. I think a sampler is just a sampler. It's a way of combining pixels. If the texture, for instance, is too small for your resolution, you can do upsampling. Uh, or if it's too big and you need to draw a smaller texture, you can downsample and so forth. So samplers are just mathematical operations on pixels. Yeah, but as long as you specify UV coordinates for each vertex, you should be able to color the vertices by a specific texture using the sampler. Um, I'm still unsure what to call you, but let me call you Mr. Yes, if you don't mind. Um, well, that sounds great. And a vertex buffer seems like the appropriate step to do now. I haven't even done my break yet because I got distracted by changing the code here. I'm almost done. So let's just do yeah. Yeah, it's really nice. The OBJ parser is fun to do. If you ever need an OBJ parser, I've written one from scratch completely myself, so I can definitely help you if you run into trouble. Actually, I also promised Mr. Yes that I would show the OBJ parser. I suddenly remember. Um, so before I do a break, I will show you both that and yeah, then I'll probably do a short break where I get some food and so forth. Um, since my buddy Mr. Yes requested it earlier, so let's see. So and Karim wanted the material system. I'll probably do that after the break, but Mr. Yes and yeah, I don't hope I butchered. Fan Fanbia, is that okay or did I overpronounce the double N? Okay, great, great. Okay, so if we take the whole application here, mind you that I'm refactoring all of this, so some of it is deprecated and due to change, but I think I can give you the generalized idea. So the current way that I set up loading of data is during the onCreate step of the application, and I actually build some resources. Um, I load in the meshes and create the transforms and texture transforms and all that kind of stuff. In this part of the application for now, it's supposed to move to a different area. But anyway, I simply call um, my OBJ reader. I don't know about MTL, but OBJ is really fast. I've loaded very complex polygons, or rather meshes, fairly fast. And you can always multi-thread it or whatever, but usually you would load a model during load time of the application anyway, so there's no need for it to be super fast. Well, I don't think you would load it every frame anyway, would you? You would kind of like store it in memory and then be able to draw it instantaneously, I think. But I'll show you how I do it anyway, since it relates to that, because the loading step is right now not optimized in any way, because it doesn't matter how long time doesn't matter in quote. Yeah, Um, but probably you would preload some assets or maybe do asynchronous loading on a separate thread to mitigate. Yeah, that would be a way of resource streaming, for instance. You could do a asynchronous loading or parsing. Yeah, okay. But yeah, you can implement some different streaming model, I think, in terms of the data flow. But sure, it seems like you have more specific targets for um, uh, a better runtime performance. I don't think this runtime performance is bad, but you could definitely do some different optimizations. Yeah, I don't think it's a problem. Yeah, should be fine. But yeah, I kind of prefetch as much mesh data I can. I also store the different kind of vertices. I build a buffer that holds all mesh information um, and kind of like appends it all together, meaning that I have one big buffer of mesh data. Oh, no, that's actually not correct. It's more like size descriptions of the meshes and how the indices are laid out. But anyway, I use the OBJ reader where I read the OBJ file. It's simply just a basic file parser here where we open a file. And then I have a custom data structure that is part of fscan. Let's see. So it basically reads a file stream. It's a C version of reading um, yeah information. If we look it up. So this reads data, formatted data from a stream. Uh, but yeah, I store each line in a line header. Yeah, kind of. They're both the same. Um, the parameter here is yeah, it's basically like getting a line. Basically like getting a line. I've done a let me show you. I've done another file parser in terms of the font. I did it C++ style. This is more C style. Uh, since I would recommend you not to use too many file streams in terms of the C++ style because I find them to be sometimes slower. Maybe you should do it C style because usually that's pretty fast in terms of file parsing. Let me see, systems, file handling, fonts. So this is a C++ style file reader where we simply use getLine for each line of the document. You could do the same. It doesn't really matter that much. And as you can see, you can use both approaches. They mix fine, and no one will be judging you if you mix. It's something related to the I don't know, information flow. I'm not sure that it actually is slower. I've just read several Stack Overflow posts that kind of like argued that it was faster to do the C-style information stream. Yeah, yeah, that's a good idea. Let's see. So in our OBJ reader, we read each line. Um, uh, and we of course store it in the buffer. And if it's equal to -1, we don't have anything to do, but otherwise we pass each line. And then we you should only optimize if you need to anyway. But yeah, the OBJ files, as you might recall, is structured in a way where the file first contains the vertices, and then let's just do a simple cube here. So first we have the vertices. We have the header. We don't care about the header. We simply just skip that. Then we pass each vertex. Then we pass each UV map. Yeah, those material files. Uh, are you using Blender? It seems like it. But yeah, then you pass the okay, I don't know that file format, but a lot of things do have a so-called material file which only contains texture names. It's kind of useless because you would have to upload your textures manually anyway. The model loading and the okay. Well, usually textures and models are stored different in different parts of memory, or at least on the disk as well, since you can map whatever texture you want to a particular model. So um, usually the OBJ file doesn't contain any texture information, and if your MTL file doesn't contain anything other than a name, it won't be usable as a texture. You would have to upload your texture separately and simply tell the graphics pipeline to map accordingly to the UVs. Yeah, yeah, you can definitely upload PNGs, I think, depending on what libraries you have access to. Um, yeah, otherwise you can use, yeah, you can do that. Anyway, for the OBJ loader here, we pass the first the vertices. Yeah, 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 sure. It's fine, no worries. And first vertices, UVs, and then the normals for the lighting. And then we get into the tricky part. An OBJ contains a series of faces, which is three vertices combined that makes out a triangle. And even though it may have the same vertex coordinate, for instance, the first part of this um, area here, the first component specifies what vertex to use. Then the next one specifies the UV, and the final one specifies the normal. So as you can see here, vertex number 5 from this list up here is shown several. Yeah, you would have to do, you can't use the MTL file for that. Yeah, yeah, it won't help you loading the texture. You need to load this information here, the vertices, the UVs, and if you want to do lighting, the normals. And then you need to upload the textures, and then you need to calculate the faces and upload that to your GPU. But this is tricky because you will end up with bad results in terms of UVs and uh, yeah, they are. So, but you need to be mindful because, for instance, vertex number 5 here is used in combination with the UV number 1 and the normal number 1. It may appear on this list. Yeah, you can see here vertex number 5 is also used with the UV number 16 and the normal number 6. So this means that this is actually a unique vertex. It is not the same as this one. And without both of them, even though they're used, they're only described using these 8 points, if you don't kind of pass out and compare these vertices and create the new ones for your buffers, your model will be weirdly textured or behave weirdly in lighting. So this is actually the tricky part of the parser. And yeah, it took me some time to get it right. But first you load all the vertices, all the normals, and all the UV maps into a buffer. And that's pretty straightforward. You simply grab all the components of that line that starts with a V for all the vertices and store them somewhere. I do a vector of float freeze. The same thing for the normals and then the UV maps. All right, but if we try to pass the faces here, as you saw, they are kind of written so that a vertex has 3 components. So you need to fetch that and store that in a data structure somewhere. And you can do some checking. And you need to kind of like create a custom data structure that is able to hold your information so that you can compare um, your current list of vertices with the new vertices that you pass, so that for each time there's a new combination of, for instance, vertex index, UV index, and normal index, you create a sort of new vertex to the list. So this uses some different comparisons here. We create a set of 3 vertices that gets read for the specific face, and then if it's the first face, we simply store it. We know there's no vertices in our buffer, and we don't need to compare ever. Otherwise, we do 2 lists. Something that is found and new, and something that is found and old. So we simply check if we already have the face components. We kind of like count up how many exists in our list already. And then if we found less than 3 existing face components, we need to figure out what's new. And we do some comparisons again. And if we didn't find any new ones at all, and therefore not any old ones, we simply just create all the vertices. Otherwise, we try to figure out how to store the new vertices, and that's it. There are different ways of doing this, and you could probably do it in a more optimized way, but this works perfectly, at least for every mesh I've tried loading. And yeah, maybe you don't need to check for whether it's already there. I do think, though, that you don't want to store unnecessary vertices. But anyway, they get accumulated into a set of buffers. Uh, which of course store the vertices, the normals, the UVs, and the indices for the index buffer. So that's the loading step. In the renderer, I do a loading step of sorts. Of course, I create the buffers, but you don't need to see that. I also upload, and this is for Mr. Yes, especially, I also upload the vertices to the GPU. I of course extract the vertex data according to the summation of each mesh. The pre-processing stores how many vertices there is in a mesh and where to offset into the total buffer of loaded meshes, which is simply one big buffer. This OBJ structure here loads everything into one big buffer. You could flush it in between, but since I will be transferring all the indices and vertices to the GPU for the same buffer, yeah, I see no reason to kind of flush the information. But yeah, I simply pass it. I pass along the normals, UVs, and so forth, and upload them to the GPU. Actually, I create my vertex and index buffers here. All right, man. Thanks for tuning in and dropping by. Sleep tight. Yeah, I know that feeling. Better to have a good night's sleep and why? Thank you. So nice to have you. Feel free to tune in and let me know how your project goes. Thank you. All right. And the last steps are, of course, uploading the data to the GPU, creating the views, and then doing draw calls. Mm. And let's see, could we actually disable all this stuff here? I think we can. Yep. And for this part of the stream, I'll do the forewarned game object split uh, in terms of dynamic and static objects. Let's just close all of this and open our application here. Let's do static game objects and dynamic game objects. Yeah, we will do a lot of refactoring and house cleaning in the future. Let's just copy this for now. Okay, now we should have a lot of red areas. Initialization don't need to be corrected. Okay, let's move this around with us. So we want to use the static game objects. We want to, let's see, where is the squiggly line on update maybe? Yeah, okay, it's inside the update function. Let's see. Let's do the static game objects. Static game objects. Nope, this is going to be, okay. Yeah, I need to leave this for now because the physics system is supposed to, yeah, run on the dynamic stuff. This is also going to be changed. This is also going to be changed. So we will leave it for now. The game objects here. We would like to do static objects here in a scope. The transform indices will be accumulated over time since we will not be using a separate buffer for that. Also, the bounding volumes are currently linked to yeah, let's just define this. So the floor, the walls, all contain static objects, which we will be moving into our static buffer here. Static game objects here. So this is for static objects. Then we will do dynamic objects. And we will do these two. and we will store them in the dynamic game objects. We will of course need to patch up our code here. -1. Yeah, because that is the let me see. How did I actually link up these things? Dynamic objects. And our characters here. Okay, yeah, this is kind of like getting to a point where it's a bit messy, to say the least. Character. Yeah, I think I'll redo that. I think I'll redo that. Oh, this is turning out to be a bit more of a refactor than I expected. Yeah, and these will have a BBs for collision. Okay, I definitely need to redo my data structures for the whole object system to streamline it. Can I actually do a scope inside a scope where I can collapse this, because IntelliSense doesn't really know what to do with any of this. For some reason I can't collapse it. IntelliSense is not really helpful. Okay, whatever, I give up. Okay. So this is basically a way to bind the physics component to... Yeah, I really need to redo all of this. This is only for static objects as well, so... create static bounding volumes for ABBs. Yeah, so let's see. Uh, this should be called ABB instead. There we go. Yeah, we're doing a lot of refactoring right now. Yeah, we calculate an OBB and an ABB for each kind of mesh. Since it's fairly quick to calculate an OBB from an ABB. Pre-calculate blade base ABBs and OBBs. And we of course change that. Dynamic bounding spheres, we got that. Let's see our dynamic object up here. Let's close this for now. Bounding sphere 0, bounding box -1. Well, maybe we do want a reset of the box index as well. Yeah, I think the order should be like this. Not that it matters, but okay. And we do a bounding box equal to object ID, and we increase it afterwards. No, not object ID, box ID. And we do a sphere index, and we do also some increment here. Okay. Then instead of doing this, we want to do a game object inside dynamic game objects, and we basically set if the obj, yeah, let's do the same check here. Because we want a mesh, we want a transform, and we want a bounding box. At least for this computation. Let's do the obj dot mesh. Reload the center. We load the transform. We will deprecate this. And we will copy this over. Let's see. And refactor it. So we want to grab the transform. We want to grab the transform. And we of course want to grab the transform, yeah. Then we want to grab the transform. Dynamic bounding boxes. Well, I don't use the AABB anymore for the dynamic objects since they can move and rotate and everything. So let's just deprecate that. I.e. delete it. And we simply store that. We could also do something like sphere and we could override the wait a minute. There we go. So that way we kind of create them dynamically. Also, yeah. Hopefully, I'm not too tired now to patch this properly up, but we'll definitely see. Anyway, that was part of the cleanup of this part of the code. This is for creating bounding spheres. Actually, do we even use this? Yeah, we do. We do use the AABB. Okay. But we only store the OBB. We got rid of the whole character thingy stuff, which is pretty fine. I think we will replace this part of the code eventually, since it's a bad system. So we reset the box and sphere indices, because for dynamic indexes we do OBBs instead of AABBs, and we do spheres, of course, which we set here. Okay, so I think Unreal Engine and Unity is really great. I think if you just want to make games, it's probably the best way to realize that. If you want to study graphics, mathematics, physics, uh, lots of different stuff, and if you want to know how everything works on a fundamental level, then yeah, you need to do your own thing from scratch. But if you just want to make games, do Unity or Unreal. Okay, we deprecate the particle system for now. We don't need that right now. It works, but yeah, okay. All right. I think our you sound like a real programmer. So I think that this is the first object is the dynamic one, or rather, this was what we used in the olden days. What's the issue, man? Well, if it's in your... Well, they are not normalized. They are never normalized. This model is only 2 units across each edge, but yeah, you could have models that are scaled differently, so that's not a problem. You can always scale the model inside the application afterwards. So if it's too big, you can just make it fit. Yeah, well then that seems exactly correct. Let's see. We grab that. We do that. We do that. Excuse me. And we do this. And there we go. Yeah, yeah. Since your model is 32 by 32, the minus 16 is probably just halfway past, um, or halfway through the center of the object, and then out to one outer edge. It's probably exactly as it's supposed to be. Let's deprecate this one now. Okay, this is some stuff that we don't use. Excuse me. Okay. Okay. Maybe this is the second one. I think so. Oh well, most models aren't. Yeah, well, that's just one of the nice challenges. Let's see, maybe this is correct. Okay, did we iron out all the errors? Okay, yeah, we definitely didn't grab all of them. Okay, let's do this during debug mode. And do a step into the function. Alright, we have a problem already way before we even get to the update step. Maybe we have a problem inside our on create. Alright, no crashes, no crashes, no crashes, no crashes, no crashes, no crashes, no crashes. Okay. Okay. Well, maybe we end up. Okay, so someplace here let's do a step into this. Where do we get the problem? Okay. It's basically doing this step down here. Let's close this for now. And this for now. Okay. Let's see. Okay, we tracked it down. So recalculate bounding box. Ah, well, we don't use the characters anymore. That's why it doesn't work. What do we want? We want to update the center of each object, or rather the bounding volume. Do we even need this one? I don't think so. I'm pretty sure it's deprecated anyway. So far, no crashes, so we might. Okay. We're getting somewhere. We're not there yet, but we're definitely not far off. Yeah, the old raycast is in terms of NAABB, so I can't do that. Let's see what error messages do we get. Draw. Huh? Okay, yeah. Maybe. Hmm. The preload static data function. Huh. Okay, I changed something somewhere. Let's see if we disable some of the draw calls, we might find out what the culprit is. Yeah, we disabled this. Okay, let's just disable one of them. Okay, we do run into trouble in terms of that. Let's see, if I don't draw the static objects, we still do end up in trouble. Where did I introduce a bug? That's the problem with refactoring. Let's try disabling the draw calls for each part of the rendering here. Let's see. That's not it. Maybe that one or that one. Nope. It's related to the debug rendering items or what? Yeah. So let's disable that for now and see if we get any more errors, because we of course changed the underlying way of computing the debug information. We will of course redo that once we have everything up and running as before. Okay. I would like to draw our guy. Let me see. So, bounding volume, dynamic bounding boxes. Let's see in our application here. Base bounding boxes. And I don't think we even do any. Huh. Where did we do it in our old part of the dynamic spheres, OBBs, static bounding boxes? We actually don't draw any um, dynamic AABBs. So although we do kind of, well, yeah, create. So this is a list of colliders. Yeah, this is actually deprecated. Let's see, plus, of course, the dynamic bounding volume size for the OBBs. We need that, the OBB, and where is our next problem? Is it inside some of this? There we go. We disable that for now. Does everything compile? It does, but we will enable this. Probably we will have a large enough buffer now. Yeah, we will. Yeah, I did. I also did the explanation of the OBJ loader previously during this stream. Yeah, I'm also in a need of a break. But if you want to watch that, you have to rewind the stream for today. I did everything as you wanted in terms of how to commit a OBJ file to the index and vertex buffers. Yeah, but you can always watch it, and if you have any questions or want me to show something again, I can always do it. Um, yeah, sure, man. And what did? Yeah. I'm sorry, Karim. I have to postpone your the review of the material system and the generalized rendering architecture because right now I'm refactoring a bit of stuff. So yeah, I need to get everything up and running. Let's see. Yeah, sure thing, man. Static bounding boxes. Yeah, I'm really tired. I can't really think anymore. So I'll have to do a break. Maybe I'll do more work. Maybe I'll call it a day since I've been working on this all day, uh, more or less. But yeah, at least we got to a point where we got dynamic object rendering, and we also yeah, we need to update. Oh, now I know why I don't see anything here. Let's see. Let me just fix that so that everything is up and running. And then I'll end the stream. But I need to fix that now that I probably know why it's not. Whoops, this is the renderer. So yeah, back in the day, I did an update of this specific game object. Instead, we want to simply uh, kind of append the dynamic objects. Let's see the dynamic objects. We did this before. What will happen if we simply do temporary, or rather the dynamic objects here? Of course, we end up in a situation where the subscripts don't match, so we need to change that. But let's pre-compile a list of texture transforms and let's just deprecate this. We don't. Maybe we actually do want to use both of them. Okay, okay. I got a different idea. Yeah, we do this still, but we simply or rather temp objects. We insert at temp objects dot end and We take our dynamic objects here. Dynamic objects, dynamic game objects, and we take the beginning and the end of the game objects. Okay, we do this beforehand so that we get an appendage, not an appendage, but that so that we append the buffers. Let's do const auto reference objects in game objects. And then we simply want to copy. Let's see. So if we take our transforms here, we can simply copy that transform and add it to the temp transform. This will of course need to be done in a more proper way, but this will probably fix our problem. And we do the same thing for the texture transforms here. I think this might help. Whoops. Let's just maybe do a pushback instead. Oh, wait a minute. Oh, I see. The compiler kind of like stared me in the face and told me that the problem was, well, let's see. If I don't do this, everything should compile, right? Yeah. So yeah. I've been very fortunate, and a lot of people have been by the channel asking questions and interacting, and so it's really great. It's been a good day of streaming. Okay, let's step into this function because I want to see why it's bugging out. Let's see. Our objects here has a size of 3. Our game meshes has a size of 5. So okay. Okay, we crashed right here. So okay, let's redo that. So our transforms. Oh, wait a minute. Now I know. It's because we shouldn't be referencing those transforms. It's because it was something that yeah, actually if I do something like let me just copy this. if I do something like this instead, transforms and texture transforms. Let's see. It might not work, but yeah, we need to change this part here. There we go. I think this might work. Let's see. Yeah, there we go. Everything is back to normal. Everything is back to normal. Great stuff. So now, let's see. Do we have the player model as well? Yeah, we do. Everything is working as intended. All right, great stuff. That is basically some refactoring of a lot of the system. There's still a lot of work in terms of deleting old code and yeah, you're exactly right. Let's see. Let's just for fun do one little change here. Yeah, we don't need this right now. Let's deprecate it. There we go. And let's do dynamic game object number 0 and change the texture to temp value. All right. We've coupled our UI with our dynamic game objects. Next, we can actually start creating objects on the fly. And that means that now our rendering system supports a sort of like a level editor. So I can create static resources that gets uploaded to the GPU, and since they don't get updated, they don't get changed. We can do changes to them anyway, but yeah. It's probably a bit more cumbersome. So yeah, the system supports that every object could be so-called dynamic, meaning that it could be changed on the fly, which is pretty great. It means that I can spawn an endless amount of objects. Let's see. Maybe we can even do several calls to this. If we simply move this if we move this for instance to the end of our render call, this will be effectively the same. But if we move this, we can actually do several calls to this, because this will just allocate some game objects to the draw calls. So let's implement the thing that we actually did before, where we render a cube dynamically. Let's see, not in the renderer, in here. We actually did this. Let's do a bit of copying here. There we go. And yeah, we do it around here. Yeah, we could also do it up here. Oh, wait a minute. We kind of deprecated the old code anyway, so let's just do it here. Delete this. Delete this. Now I coded my own UI. It it kind of works the same way as I'm GUI, but I've created my own because I use no libraries at all. No one. So everything is made from scratch. Let's see. Okay, we can do. I don't think the order matters. So if we do something like this, and we and whoops, we do like this, we could actually encapsulate this in a scope. Uh, uh, Dynamic object creations. Uh, Creation, not plural, but singular. And this should be okay, I think. Yeah. And we're back to having our square here created. And we can bind our call here. Well, this is not referenced outside the scope. Let's just do like this. Great stuff. All right, all right, all right, all right. I think we we are at a great endpoint for today's stream. I decided. Sure thing. I decided to name you Mr. Yes. I hope you don't mind. If you do, let me know what you would rather be called. Uh, but feel free to interact and talk with people as much as you want and even ask questions. Um, as more people ask questions, I kind of like try to focus on coding and then I check the chat from time to time. The less people there will be, the more responsive I'll be. But yeah, I think even though a lot of people dropped by and interacted, we did a lot of really nice work done. Uh, all right. If you have any change of preference or anything else I should use, let me know. All right. I haven't eaten for a while, and I think I should get some food and maybe some rest. The system now definitely supports a level editor. No, no, of course, but feel free to interact and ask follow-up questions if anything of the things that we discuss interest you. Everyone is welcome. That includes you. So you've been a long-time supporter of the channel. You have several certain privileges. um, Since we submit our game objects each frame, I don't think we need to update the information anymore. Only the past data, actually. Yeah, true. I wasn't saying that you should interrupt or hassle people, but just I wanted to let you know that, of course, I'll uh, make room for you if you have questions or want to chat or anything like that. So I think we will figure it all out, even if the channel grows a bit. We could do a batch optimization here where we simply I'm happy to hear you, man. Okay, we didn't need to do this. Since we wait for the upload to happen, or at least synchronize before we move on. So, yeah. This is actually deprecated and not used anymore. So we can delete that. We can also delete these data structures since we don't use them anymore. Yeah, okay. I'll do the cleanup maybe tomorrow. All right. Thanks to everyone who dropped by, interacted, asked questions, or yeah. Yeah, I think so too. Um, Thank you very much to everyone who subscribed, followed, visited the stream, interacted, liked, uh, yeah, or in other ways um, affected today's streams. I'm happy to see the engagement and the passion for game engine development and rendering stuff. So yeah, I'll definitely tune in again over the following days. And as advertised, we will do the tutorial stream within the next few days. I think I'll do it uh, Probably on Wednesday, maybe even tomorrow, but I'll be sure to advertise it on the stream. I'll probably, yeah, I'm unsure whether I'll only do it on YouTube. We'll see. But anyway, thanks for tuning in. Take care, everyone, and stay focused and strong until I see you again. Take care. Bye.